The meaning is we all will learn together, we'll all will grow together, and let there be a atmosphere of great learning and not of mutual suspicion or struggle. That's the Indian ideal of education. So we'll start with a small prayer. Uh,
Om. Om.
Om Sahana Vavatu
Bhavatu.
Sahanau
Sahano
Bhunaktu
bhunaktu.
Sahaviryam
Viriyam kar.
Karvavahai
Avahay.
Tejasvinavadhitamastu
Tejasvinamadhitamastu.
Ma
Ma
Vidvishavahai.
vidvishavahe.
Om
Om
Shanti
Shanti,
Shanti
Shanti, Shanti.
Shri Ram. A hearty welcome to all of you, and especially to our first speaker today, Dr. Harshal Bhadkamkar. Thank you so much, sir, for taking out time and joining us today in a very important course as we have envisaged the science and technology in ancient and medieval India. We started last Sunday with an overview and just an introductory session, and today we are starting with the one of the very important facet, which is astronomical advances in ancient and medieval India. And uh, we have been fortunate to have Dr. Harshal Bhadkamkar with us. I'll just very briefly introduce him. He has got a very long CV, but I'm just introducing him. He is basically PhD in astrophysics from one of the most renowned institute, Tata Institute of Fundamental Research, and has got a very rich and experience in research as well as academics. And now he's currently working in the area of quantitative finances, which is another very challenging area. And you will, as you hear him, you will know his multifaceted prowess in different topics, whether it is maths or astrophysics or what we call as the Khagol Shastra. Uh, Resides in Thane, which is close to Mumbai in Maharashtra. Sir, welcome to you. Thanks again for joining here, and we look forward to your session. Without further delay, the stage is all yours now. Thank you.
Thanks, Naresh, and thanks all of you to invite me to give this session. This is the second series that I have been participating that Naresh is holding, and I had given the nearly the same session some time back. That was in Marathi, and I've tried to incorporate some parts, and now I'll be speaking in English. So please, first of all, pardon me if something is not really understandable in my English. Please stop me and ask me. The second thing, I would also want to give some starting comments in the beginning. So some things I have done, I believe all of you could read Marathi or Hindi, kind of the Devanagari script that we call, which is also used for Sanskrit mostly these days. um, the reason I have used it in some parts is that to use names. Say, for example, I want to say Aryabhatta. Now, Aryabhatta, I could also spell it out, but I have kept it in the Devanagari script at some places. I will also speak that. So, in case somebody doesn't read that script, feel free to ask me what it is. But I feel that is the best way to say to put this. Uh, the second thing is that I will speak what I will speak. Some of it is a fact which I have taken from some books, and some of it is what I have understood from what they explained. Okay, so it's a mix of both. I will of course answer the questions. I'll try to be my best to answer the questions. Please stop me at any point, but I will plus but please make sure I'm not I don't consider myself an expert in the subject of astronomy in ancient India. I try to give you a depiction based on my understanding of astronomy, which was my core subject some time back, and whatever readings I have done on this. So it's a mixed topic. Let us learn together. So I always say this when I speak on these subjects, is that the motto should be let's learn together. So if somebody wants to give some more insights on some of the topics, he or she is very much welcome to share the thoughts. With this, I will now proceed. I will not. Um, I believe everybody can see this, right? Can somebody unmute, and I'll also move it a bit. Can somebody see the second slide? Can somebody unmute and say that you can see the second slide?
Yes, sir, we are able to
Yes,
see.
yes, we can.
Okay, great. Thanks. Thank you very much. So, astronomy, as I would say, is one of the most ancient subjects that's been studied not just in India but across the human societies. Everywhere on the earth, wherever the civilization began to form, to flourish, at some point or later, they moved to the subject of astronomy. And why did they do that? Of course, one of the very basic reason people always say is that of an awe, that people were awed by these celestial orbs that go around at a and give light. But that may be the reason, that may not be the reason. It's a quite it's quite debatable question. But one definitive thing that people did notice, the early people, was the regularity in the patterns that these celestial bodies showed. And what use it had was obviously the timekeeping, the very first use. And the second thing, they also noticed that there was a seasonal change with the patterns of movement of with some of the bodies, especially the sun and the moon. So the very first astronomy began with recording the motions of sun and the moon in the sky. I'm sorry, on the background of other stars. So sometimes the simple motion, like the daily motion, sun rises and sets, rises in the east, sets in the west, very regularly every day it does that. There's never a break. That's kind of a regularity. And then it's also noticed that these objects move on the background of the stars, which are there in like what we call constellations. Uh, so they noticed this, and that helped. That was like the start of astronomy. But then from this point, what happens is, in every civilization there is a difference in the way they looked at the things, the difference in the purpose, the difference in the uh, attitude towards this, like theorization of this and all that. That's different. So that's where the uh, study of astronomy in India is begins. So that's where we come to the topic. um, the astronomy in India can be very broadly classified. I would rather urge you not to take this classification very seriously. It's more like a continuum, but just to for the sake of understanding, we can divide it in two parts. The first part is called the Vedic period. The other part is called Siddhantic period. What difference it is, I will come to the main differences when I come to the Siddhantic periods part. But Vedic period is, as it says, it starts with I mean the works in this period are not astronomical works. So they don't cater to astronomy. Astronomy is a subject in them. Whereas in Siddhanta period, there are specific works, specific treatises, which are written specifically for subjects like mathematics and astronomy. But so in Vedic period, it's a science of time measurement primarily. It's known as Vedanga Jyotisha. So Vedanga Jyotisha is considered as a Vedanga, which means it's a secondary topic of Vedas. And it's like, by the same very notion that Vedas are ancient, we can also say that Vedanga Jyotish is also very ancient topic, maybe dating to quite a few millennia in the BCE. The specific word that they used for the rishis, I'm sorry, I used the word rishi here in a different font, but what I mean is a rishi here. They're called nakshatra darsha or ganaka. Two words are used in these texts. And what objective is of this period is to determine the time exactly, And why did they need to know the time? That was to determine the muhurta, for example, on for to do the standard rituals. I will use some of the English words which don't really mean that. So for example, I mean, when I say ritual, I mean things like yajna. Okay, now yajna is not strictly a ritual, but let us not go into that direction about what say, for example, what Malhotraji calls at non-translatables. Let's not go into those kind of areas. Let me be a bit generic here. And so that is what uh, the topic of astronomy was. To determine the time, they measured the motion of sun and the moon, and the planets sometimes, to be as accurate as possible, to determine when certain auspicious times are, certain eclipses are. They tried to estimate that was the objective. What do we get from this? So now we try to understand uh, what what were the advances of this period. And we should always remember that this is with respect to the time that we are talking about. So right, so we are talking about a time which is about a few millennia, more than 3 to 4 millennia in past. And obviously the knowledge of the science, technology, and things, when we call it as advanced knowledge, it is with respect to the time that we are talking about. So with respect to what people were knowing in general in third century BC, probably, or second century BC, this is what I think as a highlight of their knowledge. So sun is obviously the most prominent body. Let's talk about what were the main bodies, the celestial objects that recur in the discussions of this period. So sun is, of course, the foremost important object, obviously because of two reasons. First is the basic unit of time is day and night, which is related to the motion of sun. The sun rises, and the sun sets, and then it rises again. That's what we call a day. uh, I mean, the day is also called both ways, like from the sunrise to sunrise or sunset to sunset. There are both descriptions possible, and both descriptions are available in literature. There is no clear mm, preference to any of them. It is known that sun gives light to everything. The entire universe is composed of three parts: the Prithvi, the Antariksha, and the Dyav, which is like, we can call it the earth, the mid space, or the atmosphere, and the Dyav is the infinite space behind that. And the sun gives light to all the space, so the light goes everywhere. It's not only given to the earth, it is everywhere. The sunlight is, of course, very important, and people knew it, that without the sunlight, the life on earth will not be possible. So that is, of course, the reason why it is so important. But there's some other notions also that were present, or at least mentioned in some places. Is that they say that the sun does not rise or set. I mean, in the standard way, we say that the sun rises and sets. They say that the sun does not rise or set. It only goes to the other part of the earth, right? So the earth being spherical, and different parts of earth having day at any point of time, is a kind of fact that is mentioned. So it is not that for the entire earth it is the day, and for the entire earth then it is a night. The kind of understanding you will have from the flat earth theory. So flat earth understanding was not there. It is a kind of a round earth idea, where the sun goes to the other side of the earth when we say it is set. Also, so this is the daily motion of the sun, but also there is a yearly motion of the sun on the background of the stars. And it is very well recorded that sun follows a particular path on the background of constellations. What we call today is an ecliptic. It is called an ecliptic today. And it's a very well known thing that the sun moves through the 12 zodiac signs, which are particular in a particular way, right? But this is known also in the Vedic period. It's called Rita. Rita is also, by the way, the word used for the cosmic order in Vedas. So it has a significance to be called Rita. It's made by Varuna. That's what the description is. I mean, let's not go into too much into this poetic description of it. But the important thing is that such a path is known and it is well recorded in that period. The next object is, of course, the moon. Moon is the second most prominent object. It allows a time measurement of two kinds. One is that it moves on the background of constellations, one constellation at a time. It's like the fastest moving object on the background of constellations. It completes a month, which is like one full round of it in 29 days approximately, and that makes it like quickly go around object. And also it gives the phases, like the crescent of the moon. Like we also see that on a daily basis it changes its shape, from the crescent changes the shape. So that is also very well recorded and very very useful for the timekeeping. uh, Again, the interesting points to note here is that it is well recorded that moon does not have a light of its own. So something that we we know. So what I think what sometimes we miss is some of the things we take as an obvious today, right? For example, the understanding of solar system, that there's a sun at the center, all the planets go around it, moon goes around the earth. uh, the eclipses happen because the moon comes in between sun and earth and so on. I mean, that's why the solar eclipse happens. uh, all these things which are taught in school, uh, we do not understand that these are not so easy things to understand for somebody who does not have a very well understanding of what these objects are, especially like a few millennia back. This is not something easy. Okay, so when we see that people mention that moon is not having its own light, but it is reflecting the light. They don't use the word reflecting, of course, but they say that it is paraprakashita. It is a light taken from the sun, which is illuminating the moon. And then it is the angular distance between the sun and the moon that decides the phase of the moon. The crescent phase of the moon is decided by this angular distance, which is a very important observation and a very important discovery, I would say. Uh, which is known in quite some time back. Regarding the constellations, the number of constellation differs between different versions. So some people, some at some places it is called 27, at some places it is called 28. The starting nakshatra is always kritika, which is not same as today we call the zodiacs. The nakshatra cycle starts with Ashwini. Those who know the constellations a bit, the first constellation is Ashwini, the third constellation is kritika today. uh, when these texts are composed, kritika is considered the first constellation. I don't really know if it has any significance to the timing of these texts, but it might have something. There are other planets also mentioned. For example, uh, the ones which are visible by the naked eye, like the Jupiter, Saturn, Venus, Mercury, Mars. These are mentioned, and they also mentioned Rahu and Ketu, which are not planets, but in as per the Indian astronomy, they are considered planets. But they are basically the points relevant for the eclipse calculation, and they are also mentioned in this part period. Time measurement. Further, let's go into how the way they measure the time. uh, so time is that there are two ways to define a, a day. What is a day? So one way of defining the day is based on the sun, that the time between the sunrise to sunrise is a day. Or we can say that the time the moon takes to move from one nakshatra to the other is also a day. they're slightly different. These two definitions are slightly different, and these differences cause what we call today the Kshaya Tithi or the extra Adhik Tithi that happens in a calendar. So we notice in the calendar sometimes that we have a Panchami today, and the very next day is not Shashti but directly the Saptami. These two things happen between this thing happens between the two different definitions of the day. So the day is very well known. I mean, when I say, by the way, very well, again, I'll make this disclaimer again. I said that, but let me say that again. When I say very well, I mean very well with reference to the times we are talking about. Then there are units smaller than a day that are also mentioned. It's not very clearly mentioned what uh, these units are, but one very important observation is that is made is that the time of sunrise to sunset is not constant. So the time of the day goes on extending in the summers, and then it contracts in the winters. Now, what exactly is the difference? They also mentioned that within two solstices, so solstice is a Sankranti. So between the Makar Sankranti and the Karka Sankranti, the length of the day changes by roughly 6 muhurta. That's also what is mentioned in this. So they were aware of this movement, and they were also aware of they had also measured some in some way the measurement of the differences. So this is something that they know for the time period. Um, then they also know what is a month. The moon takes one full month to go around all the constellations. Uh, that is about 30 days. In actuality, it's a bit less than 30 days. Uh, and then within a month, there are 30 tithis, like Pratipada to Purnima and then Pratipada to Amavasya. It could be so the month start is both ways considered. It's not what we call today as Purnimanta and Amanta, I mean, the month starting from uh, the, the full moon day or the new moon day, both kind of systems are considered. And the month names are given after the constellation of the full moon. The practice that we still follow today, like in the month of Chaitra, the full moon day, the moon is in the constellation of Chitra. In the month of Vaishakha, it's in the Vishakha, and so on and so forth. So that practice is still followed. It's starting from the Vedic period. Now, if we compute this month, which is 29 and a half days roughly, 12 months come out to be 354 days. That's one lunar cycle. However, 1 year is defined as the time for the sun to go around one full circle, which is about 366 days. So there is additional days required to cover this. And that is how the Adhika Masa is introduced, the correction of Adhik Masa. This is also known in Vedic period, and this addition is this correction is present in the Vedic period. Let us now quickly go to what are the names mentioned in this period. So one of the primary names for the uh, astronomical histories of India is Varahamihra. Varahamihra was something around 6th century BC, maybe 5th or 6th century. I'm not recollecting exactly, but something around that. Not sorry, not BC, the CE, the 6th century CE. He was, and he has written quite a few treatises on the ancient Indian astronomy. That's how most of our knowledge about ancient history comes from these books. So he mentions quite a few astronomers of Vedic period in Bruhat Samhita. Some of the main names are these as given: Garga, Parashara, Kashyapa, Romaka, Vasishtha, Asita, Devala. All of these. Garga is of an importance because it's probably it's not a very clear mention, but there's probably some similar mentions in Greek literature about this. So maybe this can be cross corroborated. Among all these mentioned, there are five important astronomers whose works are then later used as a starting point in the Siddhanta period, and they are Pitamaha, Pulisha, Romaka, Vasishtha, and Surya. These five Siddhantas are considered as the primary main Siddhantas, and they are included in this Pancha Siddhantika treatise by Varahamihira. So Varahamihira mentions specifically these five. There are 18. He mentions that there are 18. There must be numerous more, but he mentions 18 as some subset and then five as the main of it, and these are after these. Amongst these, I would also mention that Surya is most likely not a real one. It is the reference to the Surya itself, the Surya, the sun itself, because the Surya Siddhanta is not by Surya, but it is said that it is given by Surya to Manu. With the classic story that we always hear, right? That Manu asked Surya about the inform or knowledge about the universe, and then he gave that knowledge, and that Manu wrote that knowledge, and that's how the Surya Siddhanta comes into place. And then amongst that is also the astronomical Siddhanta of that time, which is called Surya Siddhanta. So Surya Siddhanta is it's named after Surya, but its originator is it's quite, I would say it's unknown. It's not, it's named after him more like. So that's I'll take a break here, and I will I will just stop here maybe for a minute, and this is I complete the Vedic period here, and I move to Siddhanta period. The main differences are given here, but before going to the Siddhanta period, which is a bit more technical, by the way, I'll take a break here and maybe wait for a couple of questions, if any. So feel free, if or chat, if you want to chat out. I'll also read the chat.
Anyone wants to ask question, please, you can unmute and ask to Harshal ji, or you can write in the chat also. Yes, Shriji, just you can go ahead. This is a small interim break he has
Yes, sir.
suggested. Yeah.
Yes, sir. Thank you, sir. So I have one question that what is Deo, which you mentioned in the slides in the starting?
Yeah, so Dyo is the word signifies multiple things, of course, in multiple contexts. It usually means the upper, what should I say, mm, the upper loka. If you understand, so the loka is what we call, right, the Brahma loka, the Swarga loka, and so on. So Deo is as an upper loka. In this context, what it means is that, so Prithvi means the earth, Antariksha means the atmosphere, and Dyo means the outer space, the space outside the earth. So that's what is typically this meaning is assigned to them typically. So the sun gives light not just to the earth but also to the entire universe in some sense. They of course did not know that there are galaxies and all that, and all the other stars are same as sun. That was very vaguely known, not very clearly known, but yeah, they felt that the sun gives light to the entire universe.
Okay, sir. Thank you.
I mean, one thing, I mean, probably I missed saying this, and since this topic came up, so what did they think about the sun and other stars? So they, of course, they did not have this notion that all the stars are same and sun is just one of the ordinary stars in the universe. But they said that when it is the day and when you don't see any constellations, it is not that they are not there, they are still in the sky. It's just that because the sun is so bright we cannot see them. So they had this notion, they did not have this weird notion that constellations only appear at night. Obviously, I mean, we see it weird today, but few thousand years back, it is quite plausible to think that the constellations only exist in the night sky. In the day sky, it is only the sun. But they say that no, that is not the case. Constellations are still there. It's just that we can't see them. Uh, I'll move ahead if no further.
Namaste. My name is
Yeah, yeah,
Smita. I
please.
have a question. Is there any book with English translation where we can, study some more or go into more depth about this topic?
The quite few books. If you simply search for ancient Indian astronomy, quite a few books come up. I'll try to give a list after this. May not be immediately after the session, but maybe in a week's time, I'll send across a list of books.
Yes, please. Thank you, sir.
Yes, Purandri ji, go ahead.
हाँ तो
There is-
सर अभी सब लोग टेलीस्कोप से सब कुछ नोटिस करते हैं, तो वो टाइम पे कोई ऐसे इंस्ट्रूमेंट्स का कोई है, वो तो होगा ही, लेकिन अगर उसका किसी टेक्स्ट में मेंशनिंग है।
अ, वैदिक पीरियड में बहुत कुछ इंस्ट्रूमेंट्स नहीं है। मतलब इंस्ट्रूमेंट एज सच जिसको हम टेलीस्कोप बोल सकते, टेलीस्कोप तो ऑब्वियसली नहीं है, बट इवन मैं बाद में इंस्ट्रूमेंट का बात करूंगा, द इंस्ट्रूमेंट्स व्हिच आर यूज्ड टू मेजर द टाइम एंड द एंगल एंड सो ऑन, दे आर नॉट very much used in astronomy in ancient period. The ancient astronomy is an observational astronomy and a very not a very accurate one. So I would say so the angle measurements are very simple with things like sextant and angles and all these things, like, yeah. But there are these measurements like angle measurements and the time measurements, two basic measurements. They did exist. The instruments were not very sophisticated, but they were later made pretty accurate. I'll come to that a bit later when I talk about Siddhantic period.
ओके सर, थैंक यू।
Yep. All right, thanks. I'll move ahead then. So Siddhanta period, as it is called. Um, so Siddhanta is basically just a set of rules, or simply put, a theory. So it is a way to determine the motions of celestial bodies, and uh, it was made more and more accurate by as the time progresses by the astronomers of further times. Roughly, it starts with the first century CE. I would again say that one should not really make this distinction very solid. These are very continuous lines of works. One should not think that something drastically changed in 1 CE and the astronomy moved into something new. It's just that with the collective knowledge, the astronomy could also advance. What new things we see? One clear thing is that we see the use of mathematics more in this period, and we will see that with some formulae later, that the astronomers of this period were also mathematicians, or rather I would say many of them were primarily mathematicians, and they did astronomy as a secondary subject, to use it. So that is one thing, a very clear transition from observational astronomy to mathematical based astronomy. Then one thing that probably came from West is that the 12 zodiac signs instead of 27 constellations. That was another thing. Then accurate measurement of orbital period, the measurement accuracy increased significantly, uh, also because they had a very better mathematical models to do this. They were able to make better and better measurements. And then the idea of non-circular orbits, I'm specifically saying here non-circular. um, Prior to this, the orbit of a planet was not, I mean, the shape of the planet is not really something that people would discuss. I mean, they would not bother if it is or ellipse or a circle or something. It takes this much of time to go around, and this is their, I mean, they were more focused on details, and this is something of um, this is something to look at, around what people were really looking at when they were doing the astronomy studies. What were the objectives? This is something which is an important topic to study, and I would really say that what I'm going to say are my comments and not really very well studied facts. It's more like my comments, but I really feel that their intention was to study the details of the planetary orbits, not to give some abstract shapes to it. So one of the very famous shapes let me go to this. So I'm jumping the order a bit, and I'm coming to this slide. Look at the figure on the right. Okay, it is called epicycle. What is an epicycle? Epicycle means you make a circle of some radius, and then you make another circle which whose center moves around the circumference of uh, this particular um, this circle. So we see a big circle and a small circle. The small circle is rolling around the big circle. Okay, and the star is moving in this motion in on the small circle. So it moves a kind of a spiral path. It goes on in a spiral way around the big circle, and somebody who's sitting at the center of the big circle would see the path going in a very wayward direction. This was a very preferred method of orbits for Greeks. Okay, this epicycle was something that Greeks had thought of. And why did they think of this? The reason was obviously one thing that everybody observed, whoever had a even somewhat longer stretch of astronomy, that the motion of the planets is not a very regular motion. They keep going the speeds keep changing. They sometimes go in a reverse direction, what we call vakri, and there's quite many phenomena that are presented. And what Greeks had was a fascination with the perfect shapes. Okay, so a circle is a perfect shape, and what how can a non so how can a body which is heavenly body move in a non-perfect shape? So it must move in a perfect shape, and to move in a perfect shape they thought of this epicycle, which is which is a circle on top of a circle. Quite a cumbersome construction to make. uh, Indians did not really do this. Indians did not have this fascination of some perfect shapes or something. They felt that my objective is to make the prediction as accurately as possible, and I will basically make it. You know, uh, my objective is not to fit it into some perfect shape. So the ideal shape. I don't buy the theory of ideal shape. I simply take it as a whatever shape it is. So they had two theories. One is this epicycle. They also considered epicycle. They had something called elliptical shape. Not an exact ellipse as we learn today in mathematics. It was more like two circles. So the star is going at one circle, and you are at the center of another circle. So you're looking at a circle not from the center of it, but from slightly from the off center, and then this circle moves a bit. So there are different ways people try to explain the motions of this. I'll go back again to the original slide I was, because I mean jumping here will be too quick now. So there was this idea of non-circular orbits, and primarily they were not fixated to any shapes. That's what I would want to stress here. The five prominent Siddhantas, as we saw already, was Paitamaha, Vasishtha, Paulisha, Romaka, and Surya. The Surya being the most accurate considered. It's considered most accurate by many others, uh, the astronomers that followed in this period. Let us look at some of the concepts in this period. Okay, so one first thing to note is that they fixed something called a coordinate system. So to make any measurement of any positions or angles, you need a coordinate system. So there are two um, there are some very fixed circles that you need to fix them in the sky so that you can measure the coordinates with respect to them. So one most prominent circle everybody can easily understand is, I believe you can all see this figure, right? And in this figure the star represents you, so that's an observer. The observer is right at the center, and the circle which is marked as NESW, the one which is also tainted in gray, is the horizon. Okay, so that is where we are standing, and it's the horizon around us. The north, east, south, and west are the directions. Now the point at the very top of the head is called which is called zenith in English. That's why it's marked as Z. Is called Urdhva Swastika and Adha Swastika. Then we can think of a circle which goes E, Z, W, and Z1. Uh, that is Samamandala, and there's something called Yamyottar Vritta, which is NZ1SZ, which is the circle, which is the only circle that looks like a circle in this figure. So basically, with this coordinate system, we can define the angular distances from of different objects in the sky, and based on that, we can talk about, okay, today the position was this, tomorrow the position was that, so on and so forth, and we can note it down, and that's how we can keep records. So with certain fixed coordinate system, we can keep the records. There are two standard systems even used today. One is called altitude azimuth system, the other is called equatorial. I'll not go into too much of details of this. This is uh, like a geometry and mathematics. You can understand this from the figure, but the point is that there are coordinate systems fixed in this period to make the measurements understandable, translatable to everyone. So if I make a claim that the position of star is so and so, anybody can verify this if the person follows my coordinate system. So this was established. uh, then I'll go to some of the methods, the standard observational methods in this period. The first method is called the method of noon shadow. It basically is a simple point that you make a stick standing uh, on the ground and measure the shadow of it at the exactly at the noon. Okay, and the shadow moves. Uh, so as it is given in the figure, the GC1 represents the shadow um, at the equinox point. So if you are if the sun is at the equinox, you will observe the shadow as GC1, and the C1 point will move as the sun moves. As we know that the sun makes a north-south motion, which is called the ayana, the Uttarayana and Dakshinayana. As the sun does that, the shadow, the noon shadow, will change its position, and it will move along the line CC1. And by exactly measuring the length of the shadow and the angle of the shadow, we can measure the time. We can measure the horizon, the angle of the sun from the horizon. We can also measure the latitude of the location that we are standing at. And then there were more more sophisticated versions made to this. So what is shown in the figure is just a standing stick, right? But one can make a grooved stick. One can give grooves to the stick at equal distance or something like that, and they can also see where the shadows of these grooves are, and accordingly there are further measurements that were done in this. So this is one common methodology of measuring the shadows, and by measuring the shadows, measuring the position of the sun. uh, Okay, the next one is what we had seen before, is that of the planetary motions, the elliptical and the epicyclic orbits. Now, I already explained what these orbits are. What I want to mention is that there are 8 kinds of motions that in this period people try to fit the planetary motion in 8 types of motions. So there are eight variables. I mean, if we talk in terms of today's mathematics, there are 8 variables that somebody needs to decide to determine the position of a planet, and they are given in this shloka, which is like Vakra, Anuvakra, Kutila. So there are Vakra, Anuvakra, Kutila, Manda, Mandatara, Sama is like a stationary standard, Shigra, Shigratara. So total out of these are the 8 gatis are there that graha have, like the planets have 8 kinds of motions as given in this. And once you understand all the 8 motions, you can make the prediction of the planetary motions as accurately as possible. So that is what is planetary, the idea of the planetary motions. uh, Now let me go to one more concept, which is the day count method. This is used to determine the number of days between any two calendrical dates. So, for example, if I tell you that a particular man was married let us say, on the Purnima of Chaitra in the year 1041. Okay, so he was born in on Purnima of Chaitra 1041. He was married on the Ashtami of Kartik on 1000, say, 72. The question is, how old was he? Right, so how do you know that how many days elapsed between these two dates? So you know the day, you know the year, you know the month, you know the day, so you can simply subtract them, and you can calculate the number of days that elapsed. The calculation is not that simple, because there are some adhika masa that that come in this period, and there are some kshaya tithis that happen, right? So how do you know how many kshaya tithis happened and how many adhika masas that happened? So the, to give this estimate, the first thing they say that the concept of Mahayuga. So Mahayuga is a time required for a perfect alignment of all celestial bodies. Like every planet is in the same line from the sun, right? That period is roughly 43 lakh years, 43 lakh 20,000 years. That's what their estimate of a Mahayuga is. So, and then they say that in the Mahayuga, these many Kshayatithis will happen. In the Mahayuga, these many Adhika Masas will happen. So they give you a fraction. They give you a fraction of Adhika Masa per. So the fractions that I have given in this table are per month. So after every month, there are 11 divided by 703 Adhika Masa. So after in other words, after 703 months elapsed, there are 11 Adhika Masas that happen. And after 222 days elapsed, 7 tithis were Kshayadithis. So now you know that with this is my estimate of what is my Kshayaditi and what is my Adhikamasa estimate. Using these formulas and these ratios, now you can compute the number of days elapsed between any two tithis, any two given tithis. And people try to, of course, correct. So that is what the new Siddhanta means. So one of the things that so any Siddhanta will basically update the calculations of previous Siddhanta. The Ashtadha Gatihi that we discussed in the previous slide, people will give better and better descriptions of what those Ashtadha Gatis are, how to measure those Gatis. And one of the outcomes will be these ratios of Adhikamasa and ratios of the Kshayatithis. So we see three examples given here. Of course, we can see these numbers for every Siddhanta, but I just gave three examples. One is a Romaka Siddhanta, which is considered less accurate, one of the Pancha Siddhantas, but less accurate. The other one is a Surya Siddhanta, the most accurate Siddhanta of the Pancha Siddhantas. We see by just by looking at the numbers that the accuracy has gone up significantly. The third one is a figure given by Khanda Khadyaka. This is a work by Brahmagupta in, I think, 6th or 7th century. 7th century, yes. So Brahmagupta is 7th century. So in his work Khanda Khadyaka, Brahmagupta gives corrections to these numbers further. And his corrections are now not just simple ratios. So in the previous two columns, the numbers are simple ratios. Now Brahmagupta does not give a simple ratio, he gives a further mathematical correction. So what we call today in mathematics as a correction term, so as a zeroth order correction, or zeroth order term, for, say, for example, r r kshaya, the first one. So what is the Kshayatithi ratio? He says that I agree with Romaka and Surya Siddhanta. It is 11 by 703. But I have a correction to that, and that correction is given in the bracket. So if we look at this expression, we see the first term it is 1. So it is what he thinks as a zeroth term of it, or the zeroth correction, and then the first correction to it. So even now we see that there is much more algebra used for these expressions. Uh, this is very brief. By the way, this is a very brief theory of what people did in this period. Of course, there was much more than this, but I'm trying to give some very high level things about the prominent advances of this period, or the prominent topics, I would say, that people discussed. Some of the uh, instruments, I think one of you asked about this. I'm sorry. So it dealt mainly with two facts. One is the time measurement, the other is the angle measurement, and the third thing that is introduced in the Siddhanta period is the measurement of the length, or the measurement of the shadow length. So there is this Ghatika Patra. We all know Ghatika Patra. It's still used today for the ceremonies in many places to know the exact muhurta. It's basically um, very simple instruments where there is some flowing liquid from it, and the time taken to flow it completely out of it is there's a measurement of that. More sophisticated versions can come up by marking by making markings on them, like okay, this much is out, and so on and so forth. Then there are angle measurements like chakra, chapa, turiya. So we see that this is like measuring the full circle, half circle, quarter circle, and then make groovings on them and make further smaller angles. There's something called shanku, which is called gnomon in English. The shanku could be it is basically that shadow equipment. So it could be a simple stick fixated to a base, or it could be a grated stick which has some gratings on it, so that you can make finer measurement. There could be markings on it. So there are various versions of it possible. Essentially, it is made to measure the shadow length. So these are some of the basic measurement instruments used. Of course, this is I'm just giving you a very basic list. The list is more, and people also use more and more advanced instruments as further in time. So by the time of Bhaskaracharya, there are many more sophisticated instruments available, and by sophistication, I don't simply mean the new types of instruments. I also mean the very same instruments but with the better accuracy. Like you will have the same shanku, or you will have the same ghatika patra, but it is calibrated to measure much finer times. uh, with this okay, I'll quickly go through this part, and then I'll take a one final break. So now I'm mostly done with the theory part of it. I'll quickly give you the historical main historical figures of this period, the prominent astronomers, and also I'll also comment on some of the main contributions according to me they made in theoretical advances as well as observational advances. So so Aryabhatta is the most prominent one. In the 5th century, he was one of the, I would say, the most famous astronomers of India. Just give me a sec. Makes many interesting claims. Maybe the most celebrated claims of him is that the Earth goes around its own axis. Earth spins around the axis, and that is what makes the motion of the stars and the planets on the daily motion that happens is because not because these objects are going around, but because the Earth goes around its own axis. That's something that Aryabhatta claimed. Um, Aryabhatta also did many other important discoveries in the area of mathematics. I will, and many others, of course. I will not go into the mathematical works of these people. I will stick to the astronomical works. He also started something called the midnight day method that we use today. He used to call it Ardharatrika Paddhati. So when the sun is exactly at the Nadar point, as it is called, the Adha Swastika in Indian tradition, that is when the day starts and that is when the day ends. So the day is between the time between sun's two passages between Adha Swastika. He used both ellipses and epicycles. It is not really true to call it ellipses and epicycles. It is more like people tried to give corrections to these 8 gatis. That is how we should look at it. Not we should really not look at it giving shapes to them. They are more algebraic formulations, not geometric formulations. Uh, but Aryabhatta uses both kind of orbital descriptions. Then after Aryabhatta, the second prominent astronomer is Brahmagupta, 7th century. He makes he made much more detailed observations of these Manda and Shigra motions. As we have seen, he gave the corrections to them. He made it more algebraic. He did not limit himself to simple ratios, but gave it as a series of ratios. So the first step correction and the second step correction and so on and so forth. He discussed many other topics as well, like the daily and the regular motions of the planets, the full orbital periods of them, the full orbital period of moon, the phases of the moon, the crescent shape of the moon, the reason for this, the impact on this on the time measurement, so on and so forth. He was not really a follower of Aryabhatta. He was rather an opponent of him in his Brahmasputa Siddhanta. Brahmasputa Siddhanta is his first work. Pretty early in his life, he made this contribution. And especially, he rejected that Earth goes around its own axis and kind of theories. But later, he accepted his later work is called Khanda Khadyaka. That's what we saw in the previous slide, the formula from. And there he goes. He of course, I mean, people say he became more mature, and he saw the points that Aryabhatta was making, and he accepts them in Khanda Khadyaka. Importance of Brahmagupta is that his works are translated into Arabic, and they also found their way in Europe. His mathematical works are considered as the foundations of algebra across the world in some sense. We will not go into algebra here, but Brahmagupta is an important figure also in mathematics, and especially because of the spread of the knowledge that he caused. The last one in the series is a Bhaskaracharya, maybe uh, quite correctly or aptly known as um, the Mukutamani of all these. He was the great contributor for astronomy in many ways. Um, Primarily a mathematician, and he wrote this Siddhanta Shiromani. Um, he then provides corrections to planetary motions as usual. All these people in their siddhantas, they did give corrections to them, but Bhaskaracharya's corrections were very much accurate, to be useful much more in the later times. They enhanced it quite significantly. Bhaskaracharya also includes a section called, or a chapter called Yantradhyaya in his works, which is one of the main source of how we know about the instruments today that were used at that time. So these three were the main astronomers. There are quite a few more. Sorry, the first one most noteworthy is Varaha Mihira. Many people don't give him a status of astronomer, because he was more like a compiler, but he's the greatest compiler. Through his works we know about the Pancha Siddhantika and so on and so forth. He was also a great astrologer. He dwelled a lot in that area as well. Then after Varaha Mihira is Bhaskara. Um, he's a contemporary of Brahmagupta, and he 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 was a very big proponent of Aryabhatta side. Uh, Quite heavily he worked on algebraic astronomy. Uh, then after uh, so then there is a series of astronomers that were in the period of Brahmagupta or Bhaskara to Bhaskaracharya, the second, the Bhaskaracharya. The most noteworthy are Vateshwara, Manjulacharya, Aryabhatta the second, Sripati, Shitananda, so on and so forth. They mainly wrote the commentaries. There is something called a Karana Grantha. There is something called a Siddhanta Grantha, which is like bringing new theory, and something called a Karana Grantha, which is more like a commentary on these Siddhanta, which gives more like a small corrections to this as the time requires. After Bhaskaracharya, also the line of astronomers continued. Uh, the, Again, I have just given names here. There was somebody, Mahendra Suri. He was the court astronomer of Tughlaq. Then there was a famous Kerala school, I've just given three names here: Parameshwara, Damodara, and Nilakanta. But of course, it was a full lineage of many people. Many did fantastic works in things like algebraic Taylor series kind of series expansions of functions, and sine and cosine functions, and so on and so forth. Um, and then there were some, singled out families, not like schools, but more like families, where the entire family for generations uh, worked on astronomy and produced treatises. So Divakara family and Vallala family are the two very well-known families in this. They roughly were around 15th century, 16th century CE. So that's roughly goes from, I would say, 12th century to rough something like 17th century CE. Uh, that's until nearly until the the end of present world, I would say. uh, so that's a smooth transition to the present world, from where the modern astronomy started everywhere, not just in Europe but also in India. So that's all from my side. Thanks for listening patiently. I know I'm uh, beyond my time, so sorry for that. And we could again take a few questions quickly.
Thank you so much, sir. Actually, you are not beyond the time. We are well within the time, and we have got
Thanks.
another 15 minutes for question answers, definitely.
Great.
So it will be helpful when people ask something. You can further take up some points also, because we have got time with
Def-
us.
Definitely, I can.
Uh, any questions now? You can just unmute and ask, or can write in the chat box also. Any one of you. It's a very fascinating subject, I must say. आपने बहुत ही सुंदर लिया सर, और बहुत ही एक विलोभनीय विषयों में से एक है आकाश का दर्शन, और उससे उसका जीवन पर जो हमारे संबंध है उसके बारे में। कोई प्रश्न है? एनी क्वेश्चंस? प्लीज आस्क हर्षल जी. You can imagine PhD in astrophysics from TIFR. I think that one line is sufficient to now go on asking him whatever you have in mind. He is also IIT, if I'm not wrong.
Yeah, that's right.
Yeah.
I did my masters from IIT.
Masters from IIT Bombay, and then PhD from TIFR in astrophysics.
Yeah,
Yeah.
Purandri, please go on.
Yes, sir. Thank you for the fantastic lecture. And one more thing I wanted to ask कि आजकल दो ऐसे पहलू होते हैं. कुछ लोग बहुत एस्ट्रोनॉमी में बिलीव करते हैं और काफी जगह पे हमें पूरा फेक ही डिटेल मिलता है. तो कभी कभी ऐसा लगता है कि ये सच है या नहीं. बट आज आपका सुन के वी थॉट कि नहीं, ये साइंस है और बहुत ही अच्छे से हो पाता है. तो आज अगर इसके ऊपर डीप स्टडी करना है तो कौन से इंस्टीट्यूट्स अवेलेबल है एज पर यू, लाइक एस्ट्रोनॉमी पे ही अगर अच्छे से करना है तो?
uh, it's a very tricky subject. तो आज का जो एस्ट्रोनॉमी है ना, सो टुडेज एस्ट्रोनॉमी इज वेरी डिफरेंट फ्रॉम दिस. ये जो है, ये मैं मतलब मैं बार बार ये बोला हूँ, आई वुड रिपीट दिस, कि जब मैं ये बोलता हूँ कि एस्ट्रोनॉमिकल स्टडीज इन इंडिया वर वेरी एडवांस्ड, वी शुड रियली टेक इट इन द कॉन्टेक्स्ट ऑफ दैट टाइम. Okay, so when we say that Bhaskaracharya was a great astronomer, it is take it the sentence must be taken, or the statement must be taken in the context of 12th century world. Okay, so in the 12th century world, Bhaskaracharya's discoveries were much ahead of time. They were definitely not ahead of today's time. Okay, so today astronomy has gone much ahead of what Bhaskaracharya did. So astronomy as such is a very advanced topic, and it's more like a physics now. So it's considered as a subtopic of physics in many places. That's how I would say. And there are many institutes available, I would say, for this, that do fantastic work in astronomy. However, when we look at this subject, and again, that is my perception of this, or my view on this. People are definitely welcome to have different views, but what I think about this is this: why do we want to know about this ancient and medieval astronomy in India? We are not learning astronomy here. Okay, so let us make this thing very clear. We are not learning astronomy here. We are learning the history of India for a particular topic, which is astronomy. And what we know from this is about India. It is not about astronomy that we learn something. We did not learn much about astronomy today than we learn about India. And to put it in a contextual sense, uh, what we should really think about if we want to learn this subject, which is, so this subject is, in my opinion, of course, is a subtopic in more like history, is a history of sciences. So when we study the history of sciences, the objective is not how can we learn about today's science more, but how can we learn about what people thought about science. When Bhaskaracharya gave his work of Siddhanta Shiromani, what did he have in mind when writing that book? Of course, he had one very simple and obvious reason, was to give accurate motions of the planets. But why did he feel the need to measure the planetary positions? Okay, we today have different reasons for that, but it is very wrongly assumed many times that the reasons we do astronomy today, it's same as the reasons people did astronomy 6 centuries, 7 centuries, 1 millennium, 2 millennia back.
Yeah.
May not be the case. That may not be the case, and that is a very important thing to understand. So the motives that people did, motives people had to study astronomy, is something that is a more relevant thing to get from this, and that is some, I haven't talked much about this because that is not a subject which is, mm, it is not a subject which is very well settled, I would say, or very well studied. There are, of course, people do study this, but it's an ongoing subject. But what we should take from this is that it's a subject which is worth studying. Rather, I would say, for these kind of topics, it is the most interesting, or the most relevant question is this: that people did so many advances in the past. Why did they do that?
Okay.
Why did they feel the study of why did they feel the need of studying these objects, astronomical objects? They could have lived happily without doing it, right? Why did they do that? So that is something that we should really look at. Coming back to your questions, if you want to look at today, I would say that there are quite a few good institutes. There is, of course, TIFR, the institute from which I did. There's something called institute called Ayuka in Pune. There was an institute in Bangalore, Institute of Astronomical Studies. I was part of it for some time. There are, I would say, some at least 15 to 20 good institutes in India who do some astronomy work. Thanks. I'm sorry I digressed a bit, but
No, no, sir.
yeah,
Thanks a lot. You made a
yeah,
point. It was really good कि क्यों
yeah.
सब तब study करते थे. That is really point to think over. Thank you, sir. Thanks a lot.
Exactly. Sorry, Polemy, I took too much for the previous question, but what is a Ghatika and Shanku? So I'll the first Ghatika is just a unit of time. Most likely it means an hour, but it might mean differently in different times. The meanings of these units have changed, but it's a unit of time. A Ghatika Patra is basically, you can think of it like a vessel with a small hole at the bottom. You fill it with some liquid, and then the liquid drops out of it. You measure the time it takes to drain it completely. That is a Ghatika Patra. Shanku is, you can think of it as a, so you can search for something called this word. Um, it basically is a grated stick which is made stand vertically. Okay. uh, there are, it can of course come in fancy shapes, but it's something straight, mm, of which you want to make a shadow. So you can think of a sundial, right? So uh, the stick that we use for the sundial is called the shanku. um, so you see the shadow of it. You measure the shadow, the length of the shadow, the direction of the shadow. Then you can make further marks on it, like you can make it of a shape that you can measure half the length, half the shadow length, so on and so forth. And using all of that, you can measure the angles of the sun in the sky.
Yeah, thank you so much. Any other question? और कोई प्रश्न है? सागर,
Yes.
सागर जी प्लीज आस्क इट. सागर सानपुले, पूछिए, आपका प्रश्न पूछिए. You have raised the hand, Sagar ji. Is it for a question or just by mistake? Anyone else by the time? You have any question on this?
Yes, sir. I have a question. My name is Smita.
Yeah.
I want to know if, besides the 27 nakshatras and the 12 constellations, and up to Saturn is what we know as part of Indian astronomy. Is there reference to other like Uranus, Neptune, Pluto, or other constellations which are outside our galaxy and all? Is there any reference to those also in the ancient texts?
Okay, so the constellations are not outside the galaxy. Um, so what today we call as constellation is so to, so let us understand this. So the sun moves through a particular set of constellations. So there are 88 constellations as of today. As of the marking today, there are 88 constellations. By constellation, we mean that a region of the sky, and so we mark a particular region in the sky. It's like marking boundaries on the map. Okay, so you mark a boundary on the map, and then you take prominent stars in that, you fit some shape to it. Of course, the shapes are taken from the ancient shapes that people used to consider, so they're not random. It's like, but as of now, there are 88 such constellations. Out of these 88 constellations, sun goes around some specific constellations only. So when it moves around in a year, it moves through the constellations, and it moves through a very specific set of constellations. These constellations are called the nakshatras. Okay, as per the Indian sense. Now, so mm, by that, do we say that people did not know other constellations than the 27 nakshatras? They did definitely know. They knew all of them. They may not have marked as 88. They might have called it 60 or etc. That doesn't matter. For Indians, they haven't recorded it because it was not relevant. What was relevant was 27, but they definitely knew other constellations. I mean, that is obvious. I would say, so if you look at the way the Indian people record some things, they record something which is relevant. They do not go into non-relevant descriptions of it. They may go to details of the relevant parts. They may go into the further extents of describing it beautifully, but they do not go into non-relevant things. So a constellation that has never been visited by moon, they do not bother about it. But they knew about pole star. So pole star being one of the main constellations, they knew about pole star. So they obviously knew the other constellations. Regarding the other planets, they did not know them. It is impossible to know them without telescope because you can't see them. So before the discovery of telescope, nobody knew about any planets beyond the Saturn, the Uranus, and other planets. So they did not.
Excellent. Very nice.
Thank you, sir.
Yeah. Any question further on this session?
Yes, Sagar.
Hello.
Can you? Yeah,
Yeah.
Sagar.
Yeah, sir.
Go
Thank
ahead.
you for one session. I would like to know, is there today any method available to calculate the period or what has happened in the past, like a Mahabharata period or Ramayana period? Can we put some proof or establish something what we had in written documents by astrological study or some sort
it
of
is
thing?
it is a very tricky subject. I'll tell you why I think tricky. I don't consider myself an expert on this, so let me first give a disclaimer, and then I'll tell you why I think about it as a tricky subject. uh, the way it is done is that there are some astronomical positions mentioned in these texts, like for example Mahabharata. They mention that, say for example, Mangala is Mars, so Mars is in this particular constellation, and Venus is in that particular constellation, so on and so forth. And when so and so position is there, I am giving you this. So I'm making a donation to some rishi or something like this, and to mark the day of that donation, they give some description. Now, with that description, one can probably date that particular event. And since the positions of planets recur in time, that day can have certain multiple values. So one can say that okay, this might have happened in either in the 7th century, or it might have happened in the 10th century, or it might have happened in the 13th century, and so on and so forth. Now, the thing is, astronomy is not the only way of dating these texts, right? First of all, when we do that, we assume that they have done this accurately, which is not a very correct assumption as we go back in time. So as we go more and more further in time, the accuracy of the observations goes on decreasing. As a result, what they write may not be very accurate, right? So we should always remember this caveat. But let us keep that aside at the moment. Astronomy is one way of measuring the time or dating these events. There are other ways of doing this. There are linguist ways of doing this. There are archaeological ways of doing this. Then there are other metallurgical ways of doing this, so on and so forth. Unfortunately, there has not been a consensus in these different methods. And when there is no consensus, it is very difficult to say which one is correct. And when we are into such gray areas, it's probably not best for me to comment any further than to say at this point that it is um, not so settled matter. But yes, it is in principle possible. But is it the only answer, and is it the correct answer? You are not sure about that.
Thank you so much, Dr. Harshal ji. It is always a pleasure listening to you and knowing from you about this very, very fascinating subject. Regarding the today's session, we may have to stop here, even though we know there can be more questions. But our group is open. Harshal ji is part of that WhatsApp group. So
Definitely.
you can ask questions on the group, and whenever he gets time, I'll request him to answer them.
I will definitely do that.
So those other questions are additional questions can be taken on the group, since we have got one more session here. So we may have to stop this very
Hello,
wonderful session. Yes, Sagar ji.
नरेंद्र सर.
बोला.
Yeah, सर मुझे ब्रॉडकास्ट है क्या ग्रुप? I think admin can edit only.
No, it is open. It is kept open after
Okay,
every
okay.
class for 2 days or 3 days, and then we again close it. Okay. So now, right now, it is kept open.
Okay.
Okay.
Okay, sir.
And secondly, about these chronological things, we also had some very interesting sessions in our Swatantra Bharat 75 series. One is by Nilesh Oak, who has been
Yes.
working on this currently. I will give the links of that to you. Those who are interested, they can go through that. I'll also request Harshal ji to also go through that, because these are the
Yes, I have been
questions.
through that.
Yeah.
I was going to rather say that it is best to listen to some of the lectures by Nilesh Okji. He has done extensive work on this.
Yeah.
It is not my place to comment on this
But
question.
those links we can provide.
Yeah,
You can please go
definitely.
through his lecture, as well as yesterday there was one lecture on Mahabharata's reference to Yuga, Kali Yuga by Jivan Rao. So this one group of people are working on it. Let us try to understand from them, and then come back to our astrophysics to corroborate the things. That may be the wonderful thing.
Yes.
And
One question.
so here we again
Yeah.
just thank Harshal ji. Out of his busy schedule, he has given it today. Thank you so much. You have added a wonderful value to our this entire program today. Thank you so much, sir.
Thanks very much.
Yeah,
Yeah.
always a
Bye-bye.
pleasure. Yeah, bye bye.
Bye all. Bye all.
Bye.
Take care.
And on group, you can still ask the questions later on. As we said, group is kept open. Later on also you can ask. यहाँ पर हम लोग थोड़ा रुकते हैं, छोटा अल्प विराम लेते हैं 2 मिनट का, और उसके बाद सेकंड सेशन जो है प्रोफेसर अमैया जाधव, शी विल बी टेकिंग दैट. आई थिंक शी इज ऑलरेडी देयर. मैडम, यू आर देयर, आई थिंक. So we can just.
Yes, Narendra ji, I'm there.
Okay. So we'll just have a quick break.
After
just
5-10 minutes.
5 minutes. Yeah, we'll have a break of 5 minutes maybe, and then we'll start again. so that
Hmm.
second session can start from there. Thank you so much. And we'll be in the meeting only. Don't leave the meeting. And we'll start by, let us say, 11:25. We start the second session. Okay. This is 11:19 now. So about 5 minutes break. Thank you. Thank you to all of you. Same group, just a 5 minutes break. Namaskar. Welcome back to today's sessions. And as we said, we'll just start after a small break. I hope all of you are there. Can we start now?
Yes, sir.
Okay. Okay. So, yeah. So let me welcome our second speaker, Professor Omeya Jadhavji. Namaste, madam, and welcome to the sessions. Thank you so much for joining. And a very brief introduction. She has got a very long CV which is in front of me, but I'll try to just summarize it as per what I understand. She has done her bachelor's and master's in electronics and telecommunication and AMI, and also done MA in Sanskrit. Currently pursuing PhD, and she has got more than 12 years experience in teaching in different engineering colleges. Has been visiting faculty for Department of Sanskrit, University of Mumbai, and Kaivaladham Yoga Institute. She has also worked as a review member for syllabus designing of Maharashtra International Education Board, examiner for Advanced Training Institute, Mumbai, and many other institutes. She has done her R&D work at Samir IIT Mumbai as a MTech trainee and Sanskrit language expert. She has been censor board panel member for Films Division, Government of India. Has been delivering lectures in different conferences and institutes like IIT on topics of forts and castles in ancient India, ancient Indian knowledge systems, life and works of Bhaskaracharya, literature of Mahakavi Kalidas, and ancient Indian aviation technology. There are many publications to her credit in subjects like communication systems, ancient sciences, history of forts, Kautilya Arthashastra, and also conducts educational tours. She has been also associated with the Keshav Srushti Uttan, and she's member there, also managing committee member and social award selection committee, secretary formally of Yuva Shakha of Lokmanya Seva Sangha Parle, and Janaseva Samiti Vile Parle, she's core member. So a very, I guess, multifaceted personality with us from engineering and ancient knowledge systems, as well as the Sanskrit and some lot of social work and all. Madam, welcome once again, Ameya, and the stage is all yours. I request you to take over. She will be taking a couple of sessions today plus the coming week also, starting with, I think, mathematics, and then she will go to other subjects like town planning and other parts. As we go ahead, let us plan that. But today, let me hand over to her for the session. Thank you.
Thank you, Narendra ji. So I hope you have enjoyed the astronomy session, earlier session, right? Just wanted to ask ki, the participants all are from a different background or science or only arts?
No, madam, we don't keep any restriction. They are all who are willing to know about this topic. So there is no prerequisite of science background
Okay.
or particularly any field background. They are all willingly joining people of different age groups, and there is no criteria of background knowledge.
Fine. Thank you. I'll share my screen. We'll start with the mathematics, ancient Indian mathematics. You can see. So, background of ancient Indian mathematics. See, basically, we all know about the maths from the school days, right? So, we used to learn different theorems, then different number system. Starting with the school days, we used to start with the नंबर सिस्टम, राइट? सो नंबर सिस्टम में क्या क्या होता है, ये सब जूनियर सीनियर केजी nowadays they have started earlier only, but otherwise first standard onwards we used to have the basic arithmetic etc, right? So it is called as anka ganita. So anka ganita then means that is arithmetic, then we have the algebra and the geometry. These are the basic three sections of the mathematics, you can see, isn't it? So now in ancient mathematics, if we go back to the ancient things, so according to our knowledge, uh, इसका डेटिंग क्या हो सकता है, एक रफली कैन एनीवन टेल मी? Roughly dating, see, because now we have whatever we have learned from school days, it is based on the Western educational system, right? European system is there, right? Isn't it? So it is called as modern science, and our educational system, it is also based on the same thing, isn't it? So we need to first understand what are the roots of our mathematics, ancient mathematics. Okay, so we'll start with a means, as I told you, the main inventions are made, the modern science it belongs to, and main inventions are made during the 17th century onwards. So different theorems are there and inventions, for example Newton's universal law of gravitation. So all these things we have been studying since our school days, and ऐसा हुआ है कि ये पहले से मतलब because of the rulers like Britishers and Mughals etc, उनके वजह से ऐसा ही बम्बार्डिंग हुआ है कि ये ही सब यहाँ से ही स्टार्ट है, एंड दीज आर द साइंटिस्ट. But the thing is, India has the vast knowledge of or the tradition of the different sciences, and which are mainly written or based on the Sanskrit language. The script is Devanagari, but otherwise these are written in the language called Sanskrit. Fine. So we'll be just going through the different universities. Like we all know, as per the Britishers or the new Western scholars, कि Oxford and Oxford, the university like Oxford, वही establishment पहले हुआ है या ऐसा. But when we talk about India, then there are various different universities जो इंडिया में ऑलरेडी एग्जिस्ट है, एंड द पॉसिबिलिटी इज कि द साइंटिस्ट, द एंशियंट साइंटिस्ट ऑलरेडी शायद वो यूनिवर्सिटी में एज अ प्रोफेसर हुए होगी शायद, like acharyas, different acharyas were there, right? So we'll just go through the different ancient Indian universities like Takshashila. Here the dating is given. So 800 BC to 450 AD is the period of Takshashila, then Nalanda, Vikramshila, then Vallabhi, Gunashila. So all these are the different university which were exist in the ancient times. So this is one thing. If you ask me the location of those universities etc, so we can see here the Google map also of Nalanda University. So near Patna it is situated. Then these are the different remains of Nalanda University. So Nalanda University ऐसे ऐसे कहा जाता है कि नालंदा तक्षशिला जब भी डिस्ट्रॉय हुई थी, तो लाइक लाइब्रेरीज, द कंटेंट एंड मटेरियल इतना था, तो लाइब्रेरीज जस्ट अराउंड 6 months उसके बुक्स और ये सब जल रहे थे, इतना बड़ा लाइब्रेरी का कंटेंट था. ओके, So you can just go through the right now. These are the remains of the Nalanda University location. So these are the different structures. So archaeological point of view, I'm just showing few images कि कितना बड़ा asset था तभी. So if we go through the history part, see why I'm telling this, because we should know what has happened. शायद आपके जो इंट्रोडक्टरी लेक्चर्स में सेशंस में ये पार्ट हुआ होगा, बट जस्ट very in very short briefly I'm just going through these things. Okay, so Prithviraj Chauhan was the empire, last Hindu empire. Okay, so he was defeated by the Muhammad Ghori, and the Nalanda University around 1205 AD, it was destroyed by the Bakhtiyar Khilji. So that was very big loss of us. Okay. So simultaneously, if you go through the history part, then Prithviraj Chauhan, Nalanda University, Bakhtiyar Khilji ka attack, ये सब होने के बाद तभी in what were the contemporary events in 12th century? If we go through those events, then at that time period, the Omar Khayyam was the mathematician and astronomer who died in 1126 year. Okay, then Maya calendar was invented, and later in 12th century the Maya empire also destroyed. Okay, and another part is Angkor Wat temple was completed by Suryavarman Raja in 1150 AD. So these were the contemporary events. I'll tell you later on when we go through the Bhaskaracharya ji ka works. Okay, so these are the different history point of view. What are the different contemporary events going on at world level. Okay, then similarly here the Cambridge and Oxford universities. So these were established in 12th 13th century. Okay, and Fibonacci series is the famous one. So his time period is also between these. And in India at that time, the Bhaskaracharya ji bhi, unka bhi kaam tabhi tha. Will in next lecture we'll be going through the Bhaskaracharya ji ka works, for example Siddhanta Shiromani and different examples. But before that, we should understand what is the origin or root of this mathematics in ancient times. Fine. So first was I can say there are different Vedas are there, 4 Vedas. We all know about the Vedas, right? I hope screen is visible to you.
Yes,
Yes,
ma'am.
And this one, second slide.
We are seeing this Yathashikha Mayuranam.
Acha. Okay, so I'll continue with the this board only. Fine. So we all are aware of yes, Anuradha ji. You have raised a hand. Yeah, that's fine. So all 4 Vedas are there and 6 Vedangas are there, right? So 4 Vedas, Rigved, then Yajurved, third one is the Samaved, and fourth one is the Atharvaved. So all these 4 Vedas ke bhi Vedanga, which are the subsections or Upanga. These are called as Upangas. Okay. So Vedanga, there are 6 Vedangas. Shad Vedangas are there. So what are those 6 different Vedangas? In that, the Shiksha, Kalpa, Vyakarana, Nirukta, Chandas, Jyotisha, these are the different 6 Vedangas. So main Vedas are there, and Vedas के जो different अंग जो है वो क्या है? शिक्षा, कल्प, व्याकरण, निरुक्त, छंदस एंड ज्योतिष. ठीक है. So shiksha, it is related to the pronunciation Uchchara Shastra. Second is the Kalpa, in which the Achara Shastra is included. Third one is the Vyakarana. So Vyakarana, it is nothing but the grammar, Panini, Shabda Shastra. So scientifically, Panini ji has derived many sutras and words. So Vyakarana is there. Then Nirukta. So Nirukta, all these means if you go through the different Vedangas, so these are called as the Vedo ke Anga. That means if we consider Veda as a Purush, तो उसके सब ये नाक, कान, ऐसे सब आँखें, ऐसे सब इनको वेदांग कहा गया है. Okay. So Nirukta, it is nothing but etymology, Vyutpatti Shastra. So etymology, it includes the derivation of the word. So Vyakarana already hai, but Nirukta, basically Yaskacharya ji, they have given the very vast knowledge about the Vedic words in Nirukta. Okay, so Vyutpatti Shastra, that is etymology. Then we have Chandas, it is based on the Kavya. So there are different meters, right? So normally हम लोग जो suppose कुछ श्लोक कहते हैं, पठन करते हैं, उसका भी एक छंदस मीटर में उसका एक डेरिवेशन होता है या उच्चार होता है. एंड लिखना भी वृत्त या मीटर जो है, दैट इज नथिंग बट छंदस, छंद. देन लास्ट वन इज द ज्योतिष. So Jyotisha, there are again different types in Jyotisha. So mainly astronomy, Khagola Shastra. So Khagola Shastra is nothing but Jyotisha. And here the Lagadhacharya, Lagadha ji ने एक आचार्य थे, साइंटिस्ट थे, एंशियंट. सो उन्होंने ये डिराइव किया है. ही हैज गिवन द not definition but about maths, mathematics और गणित उन्होंने यहाँ पे दिया है. एंड ज्योतिष, so mathematics, it is a part of ज्योतिष शास्त्र, खगोल शास्त्र. Okay, so main quotation is this one: शिक्षा कल्पो व्याकरण निरुक्तम छंदसांचयः ज्योतिषाम अयनम च एव वेदांगानि षड एव तु. Fine. So this Ganita, regarding Ganita here, he is saying that कि यथा शिखा मयूराणा, जैसे मोर के ऊपर जो उसका मुकुट होता है, तुरा होता है, ऐसा मतलब तुरा मस्तक के ऊपर जो रहता है, वो जैसा है, उसका जो महत्व है वो अनन्य साधारण ऐसा महत्व है, राइट. सो वो जैसा है, वैसे ही गणित वेदांग शास्त्रों में अग्रस्थानी, मुख्य स्थान पे है. सेकेंड एग्जाम्पल ही इज गिविंग उपमा. उपमा उन्होंने जो दी है, जैसे स्नेक, नाग के ऊपर फणा जो रहता है, ऊपर जो मणि स्थित है, वो मणि का स्थान, या फिर मयूर, मोर के ऊपर, मस्तक के ऊपर जो धारण किया हुआ उसका स्थान है, दोनों का वैसा ही स्थान गणित का है. So as I told you, this mathematics, it is divided into actually 3 parts. Okay, so what are those 3 parts? First is Anka Ganita, that is arithmetic. So today we'll be covering 3 different basic sections in which the mathematics is base of the mathematics, but with respect to ancient times. And simultaneously we'll be comparing those points, different points, with the modern maths or science जो हमने already सीखा है in colleges and schools. Fine. I hope this background is sufficient for to start with the ancient mathematics. Yes or no? Is it fine?
Yes.
Yes, ma'am. Please go ahead.
Yeah.
Yes.
So
Yes.
first is mathematics. In that we have the arithmetic section. So first is arithmetic, second is algebra, and third one is geometry. So third one geometry, which is भूमिति, you can say. So भूमिति उसमें क्या होता है और background क्या है वो भी हम लोग देखेंगे, and we can definitely compare. So first is arithmetic. So in modern science or maths, the Roman number system is the base for number system. Means it was introduced first. Okay, Roman number system, and later on the decimal number system came. But actually speaking, the India has given the decimal number system to the world. Okay, so we'll just go through it. So concept of zero and infinity. This is the very important factor in the mathematics, and we should be very proud कि this zero term and the infinity term ये जो दिया है वर्ल्ड को वो इंडिया ने दिया है, भारत ने दिया है. ओके, सो द numbers first number system came in the Rigvedic. So as we all know, the very first Vedas are अपौरुषेय, right? So अपौरुषेय and ऋषि मुनि को दिखे है वो, right? And then later on scripting हुआ है उसका. So ऋग्वेद में there are few ruchas, suktas है. So number of ruchas in which the dasha sahasrani, panchashatani 500, dasha sahasra 10,000. So ऐसे सब numbers वहां पे आते हैं. So with this background, we can definitely say that in Vedic period, Rigvedic especially, so Rigveda is the first Adya Grantha among all four Vedas and Indian literature, you can see. So in Vedic literature, especially in Rigveda, it is the first Adya Grantha, first Grantha. So वहाँ पे ये number system exist है. Plus यजुर्वेद and तैत्तरीय संहिता यहाँ पे तो 1 to 10⁻17 तक का नंबर डेरिवेशन किया है. सो 10⁻17 नंबर तक हमारे जो पूर्वज है उन्होंने काम किया था, एंड दैट 10⁻17 नंबर इट इज कॉल्ड एज परार्ध. सो मेनी टाइम्स दैट परार्ध वर्ड comes repeatedly in the scripts like Yajurveda, Taittiriya Sanhita. Okay, so this is means as I told you कि Vedic literature में arithmetic number systems already existed. So I would like to give you more details about the zero number. So zero actually in Sanskrit it is called as shunya, right? So shunya is the zero number. So later on, see कैसे हुआ है, trading period होता गया है, tradings because of the trading. इंडिया से जो ट्रेड रूट है वो अरब में बाद में ट्रेडिंग हुआ है. सो दिस शून्य नंबर का डेरिवेशन इट इज एक्चुअली देन मीन्स it is with this slide you will come to know the journey of zero from shunya to zero. Okay, so in Sanskrit it is shunya, then in Arabic it is called as cipher करके. Then in Latin it is called as cipher. It was known as cipher. And then in English, finally, this cipher is Latin word. It is then translated into the English, that is zero. Okay. So this is the journey of zero, you can say. Now, if you ask me कि कैसे मतलब नंबर सिस्टम कैसा एग्जिस्ट था तभी in ancient times. So normally the numbers were mentioned or written in terms of different words. Okay, so different words means क्या है? Here some examples are given. हाँ, one more thing is there कि एक तो different words है and we have means the representation of the number is given with the words. This is one thing. And many times the number is written in the अंकानाम वामतो गतिः with this principle. मतलब क्या है? So normally we used to write 1 4 3 like that. So left to right reading होता है normally when we represent any संस्कृत टेक्स्ट नंबर रिलेटेड कुछ होगा तो वो लिखना है अपोजिट डायरेक्शन में या उल्टा लिखना है. सो दिस इज द इंटरप्रिटेशन. विल बी सीइंग दीज एग्जांपल्स व्हेन वी गो थ्रू द भास्कराचार्य जी का लिटरेचर और द मैथ्स. सो हियर द एग्जांपल इज लाइक जीरो इज रिप्रेजेंटेड विथ पूर्ण और आकाश. सो पूर्ण आकाश जीरो जीरो ही है मतलब पूर्ण है ना. सो जीरो नंबर इज रिप्रेजेंटेड विथ these words, not a number, because number system later on introduced हुआ है, but before that these words were there. Then one number is represented with Chandra, Bhu, Surya. So Chandra कितना है? एक ही है. फुल यूनिवर्स में एक ही चंद्र है. भू पृथ्वी एक ही है. And Surya also, there is only one sun, right? Right. So this is one representation. We can represent it with Chandra, Bhu, Surya. Then about two numbers. Second number, Netra, Kara, Karna. So ये सब है दो दो. तो two number is represented with these words. Then three number is represented with Guna. त्रिगुण होते हैं, त्रिलोक होते हैं. सो 3 नंबर का रिप्रेजेंटेशन पर वैसे हो गया. 4 नंबर वेद 4 है, वर्णाश्रम वर्ण भी 4 है एंड आश्रम भी 4 है. सो ये 4 नंबर का रिप्रेजेंटेशन. 5 नंबर इज रिप्रेजेंटेड विद प्राण बाण इंद्रिय पंचेंद्रिय पंच बाण पंच प्राण, राइट. सो ये रिप्रेजेंटेड 5 नंबर का हुआ है. देन अवतार, विष्णु के अवतार है, दशावतार है, तो 10 avatars are there, right? So wo another point is there. So in this way the numbers were represented with words. Then one more thing is in Aryabhatiya. So Aryabhatta was the scientist. In detail we'll be going through his works definitely, but Aryabhatiya, his book Aryabhatiya, it gives the easy methods for square roots and cube roots as well. So अभी हम लोग जो कुछ भी हमने सीखा है और किया है, these belong to the modern science, but आर्यभट्ट जी ने पहले ही वो इन्वेंट किया हुआ है और लिखा भी है इन आर्यभट्टीय. Then one more point is there, that is binomial theorem. So binomial theorems etc. मैथ्स में हमने कॉलेजेस में वगैरह पढ़ा है, किया है, वो भी वैसा ही है. From Aryabhatiya, this is just one of the quote or the verse to find out the square and cube root of the number. So the quotation is given. You can note down definitely, or you can take a screenshot as well. See, there are few books which are available which belongs to the different ancient sciences, and especially there is one book, small book, I'll show you. Science in Sanskrit. This is very good book, and the publisher is Sanskrit Bharati. सो उसमें जो कुछ भी दिया है वो ऐसा ही पिक्टोरिकल रिप्रेजेंटेशन है, प्लस कोटेशंस आर गिवन, लाइक रेफरेंसेस आर गिवन. सो यहाँ पे इन दिस केस द स्क्वायर रूट एंड क्यूब रूट, सो हाउ टू डू द कैलकुलेशन पार्ट और कैसा है वो भी विल बी स्टडिंग, एंड आई गिव यू द सिंपल मेथड्स ऑल्सो, स्पेशली भास्कराचार्य जी का जो है वो भी, एंड डिफरेंट ऑफ कोर्स पास्कल ट्रायंगल जो हमने सीखा है एंड एंशिएंट साइंस में है वो भी विल बी कवरिंग. ओके, सो विद दिस इक्वेशन वी कैन से दिस इक्वेशन ओनली. आर्यभट्ट, द एरा इज 5th century AD. So with this equation one should divide the non-square place by twice the square root of the square place, and then subtract the square from the next square place. So you can definitely try this equation and you can solve on your own. Okay, so these are the different simple methods, right? Now about algebra. So algebraic terms, when we go through the algebra, the main part is pi, the value of pi. Okay, so value of pi, the equation is also given by the Aryabhatta ji. So in Aryabhatiya, the value of pi is derived, and it is actually derived with the circumference of the earth and divided by the diameter. So it is up to, means in another one book is there, or Bharata Tirtha. So Bharati Tirtha, not Bharata Tirtha, Bharati Tirtha, in that also the value of pi is derived up to 31 decimals. You can imagine 31 decimal points, up to that value the equation is derived, or the pi ka value is derived. Okay, so here the Aryabhatiya and Bharata Tirtha mein, Bharati Tirtha mein bhi ye pi ka value is defined or given. So along with the pi ka value, there are again few more things in Bhaskaracharya ji ka Siddhanta Shiromani. So the period of Bhaskaracharya ji is 12th century AD. So he has given different methods. जो मेथड्स उन्होंने दिया है उनका नाम, और अभी हम लोग जो पढ़ रहे हैं वो दोनों मेथड्स, मींस वी यूज्ड टू learn the Pale's equation or intermediate equations, first degree, second degree equations are there, permutation combinations are there, right? And Bhaskaracharya ji ने already ये दिया है in 12th century. So he has written these terms in his own way, that is Kutta curve. So in his literature or in scientific grantha, the Kuttaka is the term. Then one more method is there, that is Chakraval Paddhat. Okay, so Chakraval Paddhat, in that also the equations are given. Of course, those equations are in the form of Sanskrit text. Quotations are there. Okay, so Chakraval Paddhat is nothing but right now whatever we are studying, it is Pell's equation. Then Ankapash, he has given the Ankapash, that is permutation combination. Then the concept of infinity. Okay, so he tells about the infinity, that is, he has mentioned the Khahara Rashi. So Khahara Rashi is nothing but the infinity, the concept of Ananta. Okay, so Ananta Sankalpana plus वैल्यू ऑफ पाई उन्होंने भी दिया है, एक्चुअल वैल्यू एंड अप्रोक्सीमेट वैल्यू, both he has given. Okay, then one more thing is there, that is calculus method. So in engineering or in maths, we used to have the calculus method, theorem also or method. Then binomial theorem भी उन्होंने दिया है. Okay, so these are the different things which are included in Siddhanta Shiromani of Bhaskaracharya ji. Third part is the geometry. Okay, so geometry, जैसे हम लोग पढ़ते हैं in school days, we used to have the Pythagoras theorem. Okay, but if you go through these text, जो इंडियन एंशंट इंडियन टेक्स्ट जो है उसमें हम लोग देखते हैं, या फिर यज्ञ वेदी, all rituals are performed with the help of the Chiti or the Shulba Sutra. So there is a Sutra Vangmaya, Sutra Grantha, जहाँ पे बौद्धायन सूत्र है, in which actual Pythagoras theorem, जो कैलकुलेशन हम लोग जैसे करते हैं वैसा ही उन्होंने वहां पे दिया है. सो यू कैन ऑब्जर्व हियर द बौद्धायन सूत्रम. This is actually, we know this theorem as a Pythagoras, but it was invented earlier, long back in Vedic period. So it is Shulba Sutra, Bodhayana and Apastamba. These are the different sutras, Sutra Vangmaya, जहाँ पे ये सब ऑलरेडी हुआ है. सो यज्ञ वेदी का डिजाइनिंग पार्ट है, डिजाइनिंग ऑफ यज्ञ वेदी. जैसे ऐसा तो नहीं है ना कि जस्ट मतलब स्क्वायर, इफ वी गो थ्रू द, मतलब स्क्वायर करना है, ट्रायंगल करना है, रेक्टेंगल करना है. सो ऑल द विद द हेल्प ऑफ शुल्ब इज नथिंग बट द थ्रेड, डोरी, मराठी में डोरी कहते हैं ना, तो वो थ्रेड है शुल्ब, एंड उससे वो मेजरमेंट दे यूज टू मेजर. एंड यज्ञ वेदी जो है जहाँ पे सैक्रिफाइस करने वाले हैं, वहां पे विद द हेल्प ऑफ दिस सूत्र, बौद्धायन सूत्र, डिजाइनिंग किया है. सो ये ओवरऑल इफ यू गो थ्रू द ज्योमेट्री पार्ट, सो ज्योमेट्री पार्ट it was existing long back, but because of the ब्रिटिशर्स एंड जो कुछ भी मतलब भारत पारतंत्र में था, परतंत्र में, तो उसके वजह से जो कुछ भी फेस करना पड़ा है, तो यहाँ पे एजुकेशन सिस्टम रिलेटेड भी हमारा वैसा ही हुआ है. Then one more scientist was there, that is Brahmagupta. So Brahmagupta plus आर्यभट्टीय में भी उन्होंने एरिया ऑफ ट्रायंगल वाज डिराइव्ड. सो आर्यभट्टीय में आर्यभट्ट जी ने एरिया ऑफ ट्रायंगल त्रिभुजस्य फलशरीरम समदल कोटि भुजार्ध संवर्गः, ऐसा करके एक इक्वेशन दिया है, एंड जहाँ पे हाफ बेस इनटू हाइट, जो नॉर्मली एरिया ऑफ ट्रायंगल हम लोग करते हैं, वो वैसा ही यहाँ पे उन्होंने ऑलरेडी दिया है विद दिस टेक्स्ट. ब्रह्मगुप्त जी ने उनके टेक्स्ट में एरिया ऑफ साइक्लिक क्वाड्रिलैटरल ट्रायंगल लिए है. सो यू कैन इमेजिन कि साइक्लिक क्वाड्रिलैटरल ट्रायंगल का एरिया ये मॉडर्न टाइम्स में 17th-18th सेंचुरी में डिराइव होके आया है अपने पास, बट इट वाज एग्जिस्टेड इन 5th to 10th century AD. Then in Leelavati, Bhaskaracharya means works of the Bhaskaracharya ji, उसमें लीलावती ग्रंथ उन्होंने जो लिखा है उसमें भी ट्रायंगल रिलेटेड इवन पाइथागोरस थियरम जो उसमें जो एग्जाम्पल्स दिए हैं, विल बी गोइंग थ्रू द एग्जाम्पल्स ऑफ डिफरेंट मीन्स एग्जाम्पल्स विच आर मेंशन इन लीलावती. एंड जैसे सिंपल सिंपल एग्जाम्पल्स उन्होंने दिए हैं एंड विथ पिक्टोरिकल रिप्रेजेंटेशन आई विल शो यू व्हेन वी भास्कराचार्य जी का नेक्स्ट टाइम हम लोग जब इन डिटेल थोड़ा सा करेंगे तभी एट दैट टाइम. फाइन. So this is about the geometry. Next is the trigonometry. Okay. So in trigonometry, Varaha Mihir ji was the scientist, Acharya Varaha Mihir. So उन्होंने पंच सिद्धांत, ब्रह्मस्फुट सिद्धांत, सूर्य सिद्धांत, इसमें रिगार्डिंग these sine cos terms उन्होंने derive किया है. So sine term is denoted with a ja and cosine term is koti ja. So sine cos terms trigonometry related जितना भी terms है, so basically means the trigonometry is based on the sine and cos terms. So वो सब उन्होंने इसमें already दिया हुआ है, वराह मिहिर, आचार्य वराह मिहिर. Then Madhava was the great mathematician. So माधव जी ने उन्होंने क्या किया है, तो साइन कोसाइन tangent series. Okay, so all these were derived earlier in Madhav, the scientist mathematician Madhav, उन्होंने ये derive किया है, which are similar to Taylor series. So we have already studied in academics the Taylor series. So these are similar to this Madhav ka sine, cosine, tangent series. Okay. Shall I move further?
Yes, ma'am.
Yeah. I hope speed is okay for you.
Yeah, it is quite good. It is good.
Then, so this is the Pascal's triangle. So here actually Chanda Shastra. Chandas is again one of the Vedanga. So Chanda Shastra में भी Pingala was the scientist जिन्होंने ये छंद शास्त्र डिराइव, मतलब पिंगला ऐसा छंद शास्त्र ऐसे फेमस है. So this actually लघु एंड गुरु ऐसे जो छंदस में टर्म्स आते हैं, लघु गुरु वृत्त छंद, ये जो हम लोग जब भी डिराइव करते हैं उसमें वैसे आता है, राइट. सो यहाँ पे पास्कल ट्रायंगल का भी सेम लॉजिक इज देयर. So Pascal triangle, normally if you go through this triangle, so see this 1 plus 1 2 over here, then 2 plus 1 3, 2 plus 1 3, and you have to write 1 1 1 जो triangular shape है वो वैसा ही carry forward करना है. And again similarly you can go on extending this part. So it is, one is long, so guru, s is short, so it is the combination of laghu and guru. Okay, so Pascal triangle is something like this, and same way the Chanda Shastra or Pingala has given the Chanda Shastra in similar way like Pascal's triangle. Okay. So about Aryabhatta, the different works of Aryabhatta is just listed over here. For example, means as I told you, the era of Aryabhatta ji is 5th century AD. So the rotation of Earth is given by the Aryabhatta. This is one first point. Then the value of pi. Then diameter of Earth is round. Then force of gravitation plus the period revolutions of the planets, different planets. So everything, revolution of the moon. Okay, so all these things are given by the Aryabhatta ji. सो आर्यभट्ट जी उन्होंने क्या क्या अभी तक किया है वो जस्ट एक एट अ ग्लांस, डायमीटर ऑफ द अर्थ, ये तो मॉडर्न साइंटिस्ट ने तो बाद में डिराइव हुआ है, बट ये इन्होंने जो दिया है एग्जैक्ट वैल्यूज, टाइम पीरियड, डे टाइम, everything he has mentioned, almost accuracy is maintained with those calculation, with his calculations. Fine. So this is about Aryabhatta. Then Brahmagupta in 6th century. The Brahmagupta was the another scientist who had given the area of the cyclic quadrilateral triangle. Okay. So Khandaka, Khadyaka and Brahma Siddhanta, these are the different works of the Brahmagupta ji, and the equation is given. Of course, equation is written in the, it was written in the Sanskrit, but then later on translated or interpreted, you can see. Then the Bhaskaracharya. So Bhaskaracharya ji, उन्होंने जो कुछ भी किया है, in 12th century, his time period. Do you know about the origin or the, कहाँ पे भास्कराचार्य जी कहाँ से थे, किसी को पता है? Anyone? Yes. भास्कराचार्य जी. He belongs to Maharashtra itself. Okay, so there is one place near चाळीसगांव. So चाळीसगांव के नजदीक पाटन देवी करके एक एरिया है. The पितलखोरा caves are situated in that particular area, and वहां पे एक बड़ा सा इंस्क्रिप्शन मिला है जो भास्कराचार्य जी के ग्रैंडसन है, उन्होंने लिखा है, चंगदेव जी. सो उन्होंने, सो ऐसा कहा जाता है कि नियर दैट चाळीसगांव, द प्लेस पाटन देवी वगैरह जो प्लेस है, वहां पे शायद भास्कराचार्य जी का मठ होगा, जहाँ पे बहुत सारे उनके स्टूडेंट्स थे, एंड वो उन्होंने लीलावती भी शायद वहां पे ही लिखा होगा, ऐसे कहा जाता है. So there are so many evidences related to Bhaskaracharya ji. I'll definitely show you next time that inscription, photo of that inscription, and उन्होंने just एक it was actually दान पत्र, डोनेशन कुछ दिया है. तभी के जो राजा थे उन्होंने डोनेशन दिया है, एंड वो डोनेशन की वजह से उनका मठ चालू था, भास्कराचार्य जी का. Okay, so plus the different examples which were mentioned in the लीलावती. So लीलावती में जैसे पीकॉक्स का एग्जाम्पल्स है, मंकीज का है, सिंपल एग्जाम्पल्स है, लाइक पाइथागोरस थ्योरम जैसा एग्जाम्पल्स है, जो हम लोग ऑलरेडी स्कूल डेज में किया है. बट भास्कराचार्य जी ने उनकी, ऐसे कहा जाता है लीलावती she was his daughter or shishya. So there are many myths related to लीलावती also. Okay, so लीलावती उन्होंने डॉटर है, शिष्या है, उनको उन्होंने सिखाया है गणित, अलजेब्रा. सो वो इंक्लूड किया है, उन्होंने बहुत सारे एग्जाम्पल्स उसमें दिए हैं. सो एग्जाम्पल्स में ये जो पीकॉक्स, मंकीज, स्नेक, ये सब एग्जाम्पल्स उसमें आते हैं, वो सब आई हैव बीन टू दिस प्लेस इन 2010. सो तभी हमने ये सब देखा भी है वहां पे कि nowadays also वहां पे एवरीथिंग, दीज एनिमल्स, बर्ड्स, ये सब एग्जिस्ट है. एंड उन्होंने जो आजू बाजू दिख रहा है उसके ऊपर से ही ये सब मैथमेटिक्स एग्जाम्पल्स दिए हैं, सिखाए हैं. सो idea of infinity is also given by the Bhaskaracharya ji in Siddhanta Shiromani, is one of the best work. So Khahara Rashi is nothing but the infinity. Numbers from 1 to 10 raised to 18, 17 उन्होंने दिया है, up to Parardha. Value of pi he has given. Then idea of calculus. So calculus का भी उन्होंने दिया है. One more, that जो पास्कल ट्रायंगल, छंदस, पिंगल उन्होंने किया है, वैसा ही भास्कराचार्य जी ने भी पास्कल ट्रायंगल को खंड मेरू ऐसा कहा गया है. सो खंड मेरू पास्कल ट्रायंगल उन्होंने डिजाइन किया है, डिराइव किया है. एंड द प्रूफ ऑफ पाइथागोरस जो हमने पढ़ा है अभी तक, वो उन्होंने ही हैज गिवन इन जस्ट 2 lines proof. Pythagoras proof he has defined or derived in just only 2 lines. So this is the one of the feature of his work. Then he has given the general solution of intermediate equation, second order and the first order, second order, both. Fine. Plus, so actually this equation solution was given by Bhaskaracharya ji in 12th century, but right now it is known as the Lagrange equation or formation जो हम लोग लिखते हैं. He has derived or invented this part in 18th century. So you can see the difference. Okay. Then circumference of earth also he has given in his works. Fine. So he has calculated the proof of Pythagoras hypothesis in just 2 lines. See this. So z, x, y, and this is y minus x. So if you go through this, this is the equation in which the z square is equals to 2xy plus x square minus 2xy plus y square derivation, and finally z square is equal to x square plus y square. So this is what actually Pythagoras theorem जो हमने किया है, वही भास्कराचार्य जी ने ये एकदम सिंपल डिराइव करके विद दिस एग्जाम्पल दिया है. Then circumference of the earth. So he has given the example of 2 cities and the coordinates. So cities Mumbai, Bikaner, ये यहाँ पे किया है, and the difference is 9 degree का difference is there. So 9 degree is equal to 1000 kilometers, and 360 degree is 40,000 kilometers. In this way, he has given the equations. This is just a simplified form of this Bhaskaracharya ji. The Madhav Gregory series. So as I told you, Madhav was the astronomer and mathematician So he has given the power series for theta, tan theta, etc. So Madhav Gregory series is one thing. Madhav Newton series, the factorial terms are there, and series of pi he has given. So these are the different series which are given by the astronomer, great astronomer and mathematician Madhav. These things are not visible. Okay, fine. So this is just an overview of the mathematics for today's session, I can say. And next time when we meet, we'll go through the different actual examples and the methods of the Bhaskaracharya ji ka Siddhanta Shiromani, Leelavati, Aryabhatiya, etc. So if you have questions or discussion, you can just go ahead. This is just an overview for today's session.
Yeah, thank you so much, Ameyaji. It was a wonderful introduction to mathematics, ancient as well as medieval. One question is already there. You mentioned a book. They wanted to know what is the name of the book and
Science in Sanskrit.
Okay.
By Sanskrit Bharati. In this book, the different diagrams, pictorial representation is there. The quotations are given. The name of the text, Science in Sanskrit by Sanskrit Bharati. Yes. So in that now, like metallurgy, chemistry, aeronautics, then botany, physics, medicine, primary level ka hai, but it is very nice book. And the cost is very low, that is hardly 100 rupees is there. Even agriculture, irrigation, botany, different sciences are involved in this book. They are included. One more book is there which is in Marathi, प्राचीन भारतीय भौतिक विज्ञान. इट इज बाय श्री भी वेलणकर जी. ये बुक में भी बहुत सारा मटेरियल इज अवेलेबल. All the sciences are involved, included in this book also. Parardha 10^17. Yeah. प्राचीन भारतीय भौतिक विज्ञान. I can share you the pics also. Pic of this front page of the book.
Yeah, you can put on group also.
Yes, definitely. And anyone interested, they can have this book also, Vedang Jyotish by Professor Mohan Apte. It is very good book. So Jyotisha Shastra, the methods are given. Mohan Apte sir ji ne diya hai. Plus there is one small book is there based on the Bhaskaracharya ji by Mohan Apte sir, Professor Mohan Apte sir, which is there in Sanskrit, Marathi, English, all three languages. Yes.
One question is whether there is any book on Vedic maths.
Vedic mathematics, there are many books. I'll give you the details or the names later on. Is it fine?
Yeah, surely. You can put on group also. Madam is also a member of the group. So as we said for Harshal ji also, here also, suppose you have got some additional questions which you get after some time, you can put on the group and she will answer it whenever she gets time.
Yeah.
We'll request her to answer it on the group also. Yeah.
Sure. I hope you have enjoyed this session. Small introduction of mathematics, ancient mathematics.
Yeah, it was wonderful. Use of Vedic
Yes,
maths.
it is very useful in current scenario, current time. You can have quick maths using Vedic methods.
Okay, I guess if there are no further questions, then we'll just conclude today's session. And thanks once again to Professor Ameya Jadhavji for joining here and taking out time from her schedule and starting the session on mathematics. As we said, in the coming time also, she is going to take session in the coming weeks. So we look forward to that. Thank you so much. And it was wonderful. Thanks to all the participants for being there very patiently and attending both the sessions. And this way, every week we'll be meeting same link. Every Sunday we are going to take different facets of this entirely intriguing and wonderful topic of ancient and medieval Indian science and technology. And we look forward to all those things. We'll conclude today's session with a small prayer. You can join me if you know the prayer, and you can unmute and join. Else, you can just listen, and later on we can give the text of these small prayers in beginning and end also. The prayer is a very well-known prayer, Sarve Bhantu Sukhina. So just join your hands, and we say this prayer for happiness and well-being of all. Let there be no disruption. There will be no calamities or pain for anyone. That's the prayer. Sarve bhavantu sukhinah, sarve santu niramaya, sarve bhadrani pashyantu, ma kaschid dukha bhag Om Shanti Shanti Shanti. Namaskar. Thanks. We conclude the session here. Thank you.